Access ACAP applications are essentially distributed systems that are running on their own without human intervention. And there are two major challenges to make robust applications in these situations. The first challenge is that the applications are running unsupervised without any human operator. Typically, when we install an application, the integrator or the installation company in the site have physical access to the camera, installs the application, verifies that it is working, and then leaves the camera there to run for month after month or even year after year without any human intervention. And we just expect the application to continue working in these kind of situations. So this is the first challenge, that we don't have the human cooperation which we typically see in other kinds of software, where we always have a human operator working together with applications and that can see that if something goes wrong as soon as it does go wrong. The other challenge is that we have a distributed system where we don't have full access to all the different parts. So we might have different applications at different sites that are running different versions. And the reason for this is that the integrators typically install the latest version when he is on site, but then we don't normally push out new applications. And we don't do this because we can't fully verify the system. If we had a human on place, then we could push out a new version of the application and make sure that all our installations are running the latest version. But if we don't have a human operator at the site, it might be hard to validate the system is actually working as it's supposed to do. So therefore we prefer to not touch the system after we have installed it. And in these situations, it is very useful with remote monitoring of the device fleet. And one of the tools that we use to do this is Sentry, FixedIT.ai, which is a service offering in the cloud. To get the cameras or the ACAP applications to work together with this, we need to have a client library running in the camera. And we have precompiled versions of this library. So in this video I will show you around the Sentry.io portal and show how we are using it to create, for example, the dashboard that you can see here, but also a lot more different things that are valuable for our development work. But if you want to know how you can get this incorporated into your applications, you should take a look at our example on GitHub in the repository FixedIT.ai Access ACAP Guides. And here you can find the FAP directory, which is the FixedIT applications, which means applications that are built with our tools from FixedIT Consulting. And here you find the Sentry example. And the Sentry example is a tiny application which includes the logging that is needed to create this dashboard. And the way we do the logging is that we have a precompiled library for the Sentry client. So essentially the only thing you need to do is to, in your Docker file, read an environment variable and load the Docker container and copy the libraries from this container. And then when you build application, if you do it with our build tools, you just need to specify in your FAP manifest file that you want to use the Sentry library. And this will automatically be pulled down, pre-compiled for the correct architecture that your camera is using. So going back to the Sentry portal, once you have your application up and running and reporting to Sentry, there is a lot of things that you can do with the information. We will start with one of our dashboards, the overview dashboard. This essentially gives us a quick overview about our connected devices. So in this case we can see that in this particular project we only have 3 connected cameras. We can see the different versions of the application that is running on these cameras. So up until 5 days ago, everything was running the 0.0.1 version of the application. The day after that, the 25th of May, we had several different versions running. and since then we only had the latest version 0.5 running in all of our devices. We can also see application starts, application updates, and application new installs. So in this graph we can see every time a new application is installed in a camera, or rather when the application is installed in a new camera. So we can see the onboarding rate of devices. Here we can see upgrading from older versions to newer versions. And here we can see every time the application is started. So for example, we can see here that during this day, the 24th of May, we had several restarts of the applications, in total 25 restarts, which indicates that either someone is working with the cameras, trying them out, starting and stopping the application, which of course wouldn't be the typical case, but during an installation that can be the case. And here we'll also have a few days where we have a restart. So this could also indicate an error in the application or an error in the power supply to the cameras. But we will see more about understanding these kind of errors in the second dashboard. So the last thing we have here is that we can see the total number of analytics transactions, which essentially means how much the analytics is running in the cameras. And we can see the top cameras here. So we can see, for example, that one of the cameras seemed to totally stop running analytics during the morning of the 29th of May, which could of course indicate an issue. Going back to dashboards, we have also another dashboard. We've looked at the overview dashboard now. We will take a look at the analysis dashboard now, which is more tailored to understanding the issues with applications and to know what to prioritize and what not to prioritize. So let's change the duration to the last 7 days here. And we can, for example, see the analytics duration here. So how much time does it take to process each frame in the camera? So optimally, we would like to do our image processing at full frame rate, which would be 1/25 of a second, so 40 milliseconds. And we can see that we're actually under that here, so we are capable of running at full frame rate. But we can also see that here something happened during the 29th. Suddenly the analytics time increased from 20 milliseconds to 33 milliseconds. So roughly a 50% increase in time. And in the right table here we can see the same measurement but broken down by release version. So here we can see that version 0.1, 3, 4 had the same 20 millisecond duration, but when releasing the 5th version, the duration had increased. So we have now isolated which release was the cause of this decrease in performance on the devices. We can also see the error count from devices. So during the last couple of days we haven't had any errors at all. That's good. Back here we had a few the 25th and 24th. But it seems like we have corrected these now in the latest minors. And we can see if it's logged as error or a fatal error. We can also see the error messages broken down by release instead of error type. So we can see which application version triggered the error. And we can also see which camera MAC address that triggered the error. So we can see if we have any specific kind of cameras, for example, because this is also another challenge when working with cameras, that we don't have one unified environment where our application is run. We have a lot of different camera models with different CPU architectures, different firmware versions and so forth. So if we can pinpoint which devices an error occurs in, it will be easier to understand what is the cause of the error. And we can also see the total message count broken down by info, fatal and error messages. And the idea with this is that when the number of cameras on board in the system increase, the number of errors will increase, because we are not typically capable of keeping the errors to a 0 incidents. But here we can see the relation between the number of total messages from the cameras, which are roughly proportional to the number of onboard cameras, and the number of error messages that is triggered. So we can see if the ratio of error messages or the relative frequency of them is increasing or decreasing. And down here we can see the application restarts broken down by cameras, filtered by the top, the cameras with the most number of restarts. So here we can see if it is one specific camera that is unstable. For example, the camera with a MAC address ending in 41FC, we can see that it had 18 restarts during this single day, which means that something is definitely wrong with that particular installation. Either the power supply is bad so that the camera is restarting, or the application has perhaps a memory leak or some kind of issue that is occurring every now and then on this specific camera. So that is something that we would need to dig down to and find more information about. So if we want to discover more information about these errors, we can go to the Discover tab, and we can essentially see all the messages that we sent from our cameras. And here we can add new columns to the table, for example. So if I want to add the camera name or MAC address here, I can do that and see which camera it was triggered on. And we can do filter, so perhaps I want to filter on release version. And here we can see the different tags of the messages as distributed on this filtered type of event. So on the third release of our application, we can see roughly the time span when these applications were running. And we can see that 100% of the applications were running as the root group and the root user. So let's now change to our latest release, the 0.5 release instead. We can see that it's been active later, and we can see that now we have 100% of the users are running as SDK user, which is a non-privileged user, and the same with the username and group here. So we can dig down into different issues. We can filter on different devices, filter on different firmwares to understand the things that we don't directly understand from the error messages or the dashboards that we have. We can also do remote performance monitoring. So these cameras are running in analytics. We could see in one of the dashboards that we had a graph over the analytics duration. And this is created by doing a profiling span where we basically log the start and stop time, so we get duration of different parts of the application. So in this very simple example applications, we just have two different spans. We have our main loop, which is running, and then we have the analytics, which is actually doing the analytics on the frame. We can see here that we have an average of 7 milliseconds in 75% of the cases, or lower than that in 75% of the cases. And we can see that the get frame function usually takes 26 milliseconds, which is of course, since we are waiting for a new frame, since we're making the processing quicker than the camera is actually delivering frames. We can also, just as I said before, see that we have suspect tags here telling us that this particular camera had 23% slower average time, and we can see that it has another OS version. So if we had a bit more logging of particular details, we could do more breakdown on to analyze if it is due to change in the camera model, or if it is due to a change in the firmware version or application version and so forth. Or of course it is something with the settings in the application. So the more information we log, the more information is available to break down and understand the root cause of issues. So if we go into the analytics part here, we can see the analytics time over the dates. And also here we can filter on different release versions. We can filter on different camera models or camera names and so forth. So this is very useful to understand not only how our algorithms are working in our controlled environment, but actually in real development where the algorithms are running at the customer sites. So if we would have one particular customer that is using it in a strange situation where we get much poorer performance, for example, we might have a detector or a object tracking with in a scene with a lot of objects, then we could see that one of the scenes would be considerably higher time for the analytics here than the other scenes. And then going to issues, we can see error messages or things that have gone wrong in the applications. So for example, we can see here that we have some camera that has sent a message about failing to get frame. So if I click this, we can see this particular message. The information is interrupted system call. So that might be something that we need to handle in our application to deal with in a nicer way. We can also see what username and group the application was running at. We can see the MAC address of the camera which this error message happened on. And we can see that this was in development environment, so it's perhaps not very interesting. We could filter for this, of course, to get rid of the development environment and only use production environment. And we can see that it was the 0.5 release of the application. So this is one particular message, but we have multiple messages with this same error message. And if we go to tags, we can see all of these messages, how they are distributed over the different tags. So for example, we can see that it doesn't seem to relate to which group name or username the application is running at. It is mostly happening on one of the cameras, but it has happened on another camera too. Yeah, we can see that it happened a lot more in the 0.1 release. So yeah, this is how we can dig down into specific error messages and see what are the cause of them. And here we can of course select production environment and see that we don't have any messages in the production environment, which is very good. So this was a quick overview of how we are using Sentry.io to monitor the applications in deployment to make sure that they are robust, they are working as they should, and we know the state of all the applications. We know if an error occurred even before a customer needs to call for support. So yet again, if you are interested in using this, I recommend contacting us, and it's really easy if you build applications with our tools and use our precompiled libraries. So you can always reach out to us at FixedIT Consulting, and we will help you and discuss what is the best solution for your needs.